So for today, it's Venn diagrams again. And let's just make sure that you really get how these work, especially with the union and the intersect. I'm just going to save us some time and go with this is apples and this is bananas. And we want to put in some data. This is going to be 2, this is going to be 3, this is going to be 5, and there's going to be 4 people out here. If I asked for the probability that I grab one of these people and they like apples, union, bananas, do you remember what that means? Everybody try to figure that out, and then it's a fraction, of course, because it's a probability. And compare your answer with the kid next to you.
14.
If you remember union. A union B. Same thing as OR. In case you forgot this, I like to think of this as a little OR. A little O on the one peg and a little R at the top of the other peg. It means OR. So, if you ask these, do you like apples or bananas? They would say yes, I like apples. If you ask these, do you like apples or bananas? They'd be like, yes, I like both. Do you like apples or bananas? Yes, I like bananas. And so you put all of those together and you have 10 out of 14, which does reduce. Raise your hand if you had that answer. Good. Any questions about that? So OR is, I know it's counterintuitive. I would think ORs would be small answers, but they're big answers. I go back to this example. If I said, raise your hand if you are if you have a dog, if you have a cat, or if you have clothes on, pretty soon everybody's raising their hand. It's a huge answer when you have or. But and is the other way around. I'd like you to, instead of like telling you this question, I'm going to write it with A and B. Do you guys know the right name for the symbol for that? I think you probably know it's an upside down U, but do you know what it's called? Intersect. And I think that name gives it away because I think you all know that's the intersection of these two. So then this would be 3 out of 14. And again, I'm not going to worry too much about reducing on these because you'd be dividing them and getting a 3 decimal place answer, like 0.626, that kind of thing. All right. So with that reminder of the last time, let's get into the notes. This is just reminding you that OR is that symbol. I like to think of it as a little O and a little R on top of each peg. I like to think of this as an A and D because it's kind of like the N in the word and. Okay, and I also remind you that ORs are big answers. Feels like they should be small, but they're big. And of course, ands then are the other way around. If I said, raise your hand if you have a cat and a piano and an SUV and you live on a body of water, it's going to be all of a sudden a really small group. Okay, this is one we didn't talk about yesterday. A with a little dash means complement of it. I think a better word for it is not. Please write that in. That's not A. So if we look at this thing, apples and bananas, let's say, is what the A and the B stand for. Then not A means these two. Do you get those two? Both of them are not A. So then if I wanted the probability of that, it would be this or that, and or means add. So then that, because you get a big answer. So then this is 7 out of, well, everything was possible, so 10, 7 out of 10. That makes sense to you? So not. So if I said the probability of snow, we obviously had that. We had snow. We didn't have as much as they thought we were going to have, so dang, we didn't get enough to actually get a e-learning day. But what if I had said snow with a little dash? What do you think that means?
No snow.
Not snow. So there is a really simple way to do this. If it is just like two things, snow or not, then if you know the probability of snow was like 70% chance of snow, then what would the probability of not snow be? 30. Just has to be the other part. All right. So probability of snow not. Complement of snow, 30. And complement means that basically they go together well. They complement each other. Okay. Move on to this. Susie has a math quiz and a French quiz on the same day. Now, these are what I've found kids get wrong the most on the test. I think so far you've probably been saying this isn't that hard, this isn't that hard. These are like a little puzzle. And you got to try to figure out what numbers go here, here, and here, and here. And the biggest screw up is people will see, oh, the probability she gets an A on her math quiz is 0.85. So then I can just put math 0.85 right here. Nope. Why can't you do that? Because in here and here together is 0.85. Did you catch that? Okay. The probability she gets an A on both, that one is 0.80. That means she got an A on both of them. Now that one you can put directly in. Now do you get that if this one is 0.85, that must mean that this is 0.05, so that together they make 0.85? All right, I need to do a new one that's like this. So everybody go off to the side, make me 2 circles. We're gonna do apples and bananas again to keep life simple. And I'm gonna tell you some facts about this and make sure you don't have the bad habit of putting the answer just like right there. All right, so make 3 lines in and 1 line out. I'm gonna tell you some facts about this class that I pulled and how much they like apples and bananas. 10 people like apples. A total of 20 people were polled. So far, you can't put anything in your circle. If you put 10 people like apples right there, you missed the whole point of what I said a second ago. That is not 10. There's 2 spots that together make 10. Apples is 10. The whole group was 20. Here's where you can put the apples was 10. You could put a 10 here. But we don't know what's here and what's here yet. Together, those will make 10. You get what I'm saying? People that like apples is 10 includes both the middle section and the left section. Now, 20 people were polled. There's the standard place to put that. Outside the box in the upper left-hand corner, that's where the grand total goes. So I still can't figure out any of my 4 blanks yet. Now, if I tell you one more piece of info, I think, no, that's still not going to be enough to fill out everything, but we could start. I'm going to tell you one more piece of info. It's going to be 5. I'll tell you there was 5 people that liked neither. 5 in the neither. And I'll also tell you all right, so I got to give you one more piece of info. There's 6 people who like both. Now you've given you enough info that you can for sure know all 4 spots, all 4 blanks. This is the first one like this that we've done, and these are the hardest thing on the test. So we're definitely going to practice this more. But see if you can use logic, and then I'll show you how to do it in a second. But see if you and the person next to you have the same answer for those 3 blanks, or 4 blanks. If you have already compared with the person next to you, would you raise your hand so I can see how many people have compared? Okay, thank you. Chase, can you tell me what the center section is right here?
6.
Yep, because they said they like both. That's one of the only times you can put it in directly. And this was also actually a direct one. But this apples is 10 wasn't allowed to go right in, but now it tells me that that's 4. Because together they make 10. And then you can use this last piece, this plus this plus this, we don't know yet, plus that has to add up to 20. Therefore, that must be a 5. Raise your hand if you had that one right. Okay, awesome. Now, I gave you a long description of that one to help you. Now go over here, and when I've started it, and use that same principle. If they give you a number, you can't just stick it in there. Unless it's one of those rare, oh, I'm lucky, I get to put it right in a blank. So there's one number here that they give you, no, 2, that you can stick right in. But then you have to use math and logic to finish this off. This time we don't know how many people there are, but we know that it'll add up to 100% because it's a probability Venn diagram. Ms. Long, can you tell me one more thing that they tell you that you can put directly in?
The probability she gets an A on these.
Yep, that goes right there. 0.05. And then how do you finish it off? Do you know how?
It's 0.8 plus 0.05 plus 0.85 is 0.9.
That's 90%. So what's the last thing got to be?
0.1.
10%. Yep, adds up to 100%. Guys, get that? These are the ones that get marked wrong the most. Now, we've spent a lot of time on it, which makes me think you're going to be okay, but all right, now that we've got the data, yay, this all adds up to 100%. Now you can actually answer probability questions with it. Would you please answer these 3 tests? And this is important. You got to decide no, on this kind, it's got to be out of 100%. They didn't ask you any that were what are called contingent questions. That'd be where, like, I'm only going to talk to the people who speak French. Then it would narrow down your answer, and it wouldn't be out of 100. They didn't do that to you on this one. So these are fairly easy. Get those 3 answers, compare with the kid next to you. 0.9, 0.95, and 0.1. Raise your hand if you agree with him on all 3. Okay, awesome. Any questions about how that happened? I know some people are probably like, I thought it was 10% got an A on the French quiz. Well, these guys also did. They both got an A on the French quiz. That's why it's 0.9. All right. Math or French quiz, or is a big answer. Put all 3 of these together. You could ask them, did you get an A on the math or the French quiz? And they'd say yes. These would say yes, and so would these say yes. All right. Not get an A on French. That's basically not French. And that's these 2. These were not French. These were not French. Not getting a French A, that is, anyway. And put those together, you get the 0.1. All right, moving on. Wow, there's a big, like, double star that makes it really obvious. This is a conditional probability. The given thing narrows down the sample space. I'm going to say that differently. It changes what it's out of. Did you guys catch that? It's not out of 100% anymore. Given she gets an A on her math quiz, well, that just narrowed down. Can't use that, can't use that. Do you get that we can't use those because it says she got an A? What's the probability she also gets an A in her French quiz? And I totally get you're thinking the answer is 0.8, but it's not. It's 0.80 for, that's the one we want, but what's possible isn't 100% anymore. Only these two were possible. So last time we could have been adding this all up to 1 and dividing it by 1. But we didn't because it was just super easy. But now we have to put these two together is what was possible. So 0.85 goes on the bottom. I want you to process that. This was not out of 100% because we didn't ask everybody. We only asked the people who got an A on math, which narrowed it down. Okay. We're going to do another one like that right now. This time, new question, same diagram. Given the person did not get an A on French, given not A on French, what's the probability they got an A on math? Remember, the given thing changes what it's out of. It's not out of 100% anymore. Given they did not get an A on French, figure out which ones you can even use them. Okay, when they say given not A on French, I'm crossing these off. And these are the only things that are possible. This is what you want over this is what is possible. I said we keep coming back to that, and here it is again. Those two that are possible go on the bottom, and they together make 0.05 plus 0.05 makes 0.10. What I want is people that got an A on math, which would be these. 0.05 over 0.10. And that is 50%. If you divide those, it'll say 0.5. There's a 50% chance we would have gotten a person who got an A on math. Second hardest question on the test is when we do this conditional probability thing where we say, given this. All right, I'm going to give you one more example of that. Everybody copy this down. Dog people, cat people, or both. This is going to be right-handed people, left-handed people. Then the question is, if I'm putting in this data, 2, 3, 1, 2, 4, 1, and then I would add them all up. 4, 5, 6, 7, 3, 4, 5, 6, 2, 3 is 5, 1 is 3, 4, add them all up. Adds up to 12. Wait, something's wrong. 5. That's got to be a 5. There we go. Adds up to 13 there. Okay. Here's one of those complicated ones. Given lefty, what's the probability of dog? It's not out of 13 because it was given lefty. Compare with the kid next to you and see what this answer is. Yeah.
From what?
But Mr. Server, I don't understand why it's not out of 13. Because you could only talk to lefties. So all of a sudden, this is the only thing that matters. So what's it out of? 6. That's what's possible. Only those 6 people were asked. Then what's the probability of dog? The ones we wanted? Those 3. So it's 3 out of 6, 1/2, 0.5. Raise your hand if you had it right. Okay, cool. That is called conditional probability. See, usually people are used to putting it out of 13 and they get those kind of questions right. But when we say given, it changes the denominator.
6 because one person is both.
Uh-oh, maybe you might have got us here. Okay, now how did I say the question? Because this matters. Did I say probability that you would only have a dog or just probability that they had a dog? Do you get the difference? If I said the probability that they only have a dog, then we did it right. But if I just said probability they have a dog, which I think I might have, if I said probability they have a dog, that includes these people because they have both a dog and a cat. So then you're right. If I said that, which honestly I can't remember anymore, then I'd have to add these together, and it would be 4 out of 6. Do you get the difference there? Because these people, both of those groups have a dog. Okay, thank you for catching that. Do another one like that. Actually, I'm going to go back. Moving on. Yes, question? Even I made a mistake on the given one. All right. This, I don't think is going to be the hardest question on the test, but I mean, these are up there. These are in that R3 kind of category. There's no parentheses, so then you just go from left to right. You got to remember if this means or and. It's going to help so much. Does this mean or and?
Or.
And as soon as I say that it means or, do you remember if that's a big answer or a small answer?
Big.
Big answer. That should help you. And then I personally change these to things like apples, bananas, and I don't know, carrots. Good. And then I ask myself, apples or bananas? I win if they have apples, if they like apples or bananas. Oh my gosh, that's a ton of numbers. All of those? Yup. Or is big answer. Or cats. Then I got to include that in my answer. So if I add those all up, 6 plus 10 is 16, 21 plus, I think I got 28. Raise your hand if you got 28. Good. But is this even asking probability? Does it say probability? No. So then it's 28. The end. If you divided it by how many total, I get why you did that, but it didn't ask you for probability. It just wanted how many people. All right, the next one. Similar, except and is a small answer. Because like if I said you have to have a dog and a cat and a car and live in a house and have hair, that's going to narrow it way down. So this is like they have to like apples and bananas and carrots. How many of you knew the answer was 5? Raise your hand if you did. Okay, awesome. Apples and bananas would have been these two, but then when you factor in they had to also like carrots, then that too isn't possible anymore because they don't like carrots. All right. How about not A? Well, if you knew it was not A, then you pretty much win. It's going to be all of those. I think that adds up to 24. Am I right on that? What if I wanted to make it a probability? Well, then I just divide by how many there are possible. Which you probably want to add them all up. It'd be 24, 29, 30, yep, 36. So you just divide it by 36 if it was a probability question. All right, next page. I said these were the hardest. See if you can pass the challenge. Remember, the 125 has a place that it goes, but it's not one of the blanks. The 60, let's all agree that this is A, and this is B, and this is C. Otherwise, you're going to be really confused when you compare with the kid next to you. A is on the left, B is on the right, C is the one on the bottom. Okay? Then, that 60, it does not go directly in. 60 is newspaper A. I'd put it here. The 125, I'd put it outside, kind of on the left. It's fine if it's, there versus above. But it's not inside the box. It's the grand total, so it's outside the box. And the A with the 60 after it means all 4 blanks add up to 60. This is like the ultimate logic puzzle for math. It's kind of like a Sudoku or something. And these are what I mark wrong the most on the test. I'll pause while you give this challenge a try. Okay, pro tip on these. Find the middle. They usually give you the middle because it's really hard, really, really hard if they don't, but they did. See this 15? That's something that you almost always are given, and it really, really helps to put it in. So that 15, that's all 3. A and B and C is 15. This goes right here, and it's a 15, and that really helps. Okay. I'm going to try to show you how I would have done it. I'm going to kind of go and write each number where I can write it. Like this 22, read A and B. That means together, these together make 22. Well, then I can use logic since I already placed the 15. That's why I said to do that. Now I can say that this has to be 7. Because together they had to be 22. All right. 35, read A and C. So I'd go like this and say that together is 35. I should really put it outside here. And then that must be 20 to make a total of 35. And 28, read B and C. So these together are 28. And so 15 plus what makes 28? I think it's 13. I agree. And now I've done that one. And now 15, I already did that one. Oh, I have one more piece of info that's really handy. A is 60. So together, all 4 of those spots add up to 60. I've already got 35, 42 of them. I think that leaves 18 there. Can anybody verify that that's 18? Yeah. Okay, good. And, I missed one up here. 50, read newspaper B. So that's got to be 50. And 75, read the last newspaper. So that's got to be 75. And now I'm adding up all the B's to add up to 50. So 10, 20, 35. So this must be 15 to make it go up to 50. And all of these add up to 75, 20, 35, 48, 9, 50, 22, 27. Can anybody verify 27 there? Yay. And then, pain in the butt, I got to add them all up and make sure they add up to 125 when I put the right number here. Would you save me some time? You probably already did it. What'd you get? Maybe you didn't. Is that your prediction is going to be 10?
Yeah, I got 10.
Okay. All right.
10.
So now I'm going to ask and see how good Siri is at this. What is 125 minus 18 minus 7 minus 15 minus 15 minus 20 minus 13 minus 27? 10. Yay. You see why they could probably mark that one wrong more than any other one? There's a lot of little logic leaps you have to make, but you got one for your homework for tonight. You can practice it there. All right. So let's do this last slide together, and then I think we'll be good and ready to go. So whenever there are percents like this, you can know they all add up to 100%. I'm going to put a 1.0 up there just to remind me that adds up to 100%. Probability of A. Most common mistake is somebody slaps down 144. No. It's all of the things in the A circle added together. These numbers are so weird, it'd be definitely handy to have a calculator. This is the part where I'd like you to either get out a graphing or a regular calculator, but have one on your desk. If you wanna, you can pull up the iPad's calculator and show me that. So please take your iPad calculator out or the calculator from your backpack. I'll be walking around in a minute to have you show me which one you have chosen. I'm okay with either, but you'll need a calculator out and handy. All right, show me. Good. Works. You're not using it tape with that phone needs to go in the backpack?
Oh, yeah.
Good. Thank you. Good. I personally think you should get used to the calculator. You know why? Because you don't get to use the iPad on the test. Cool. Thank you. Okay. Everybody is verified using a calculator. And so for A, I just have to add these up. What is 0.144 plus 0.056 plus 0.12 plus 0.16? Did you guys get 0.48? Mm-hmm. Excellent. So then I personally changed this next problem into two things. I changed it to OR because I know that's what the union means. And I remember that that's a big answer. And then I think, oh, big answer with B and C. Oh, I guess it's probably all of these. And it is. What is 0.056 plus 0.12 plus 0.12 plus 0.16 plus 0.104 plus 0.216? I get 0.776. Did anybody get the same thing?
Yeah.
Okay. You have a question or comment?
Comment. So, because the amount of decimals that you added were bigger than 2, you could just subtracted the 2 other decimals from 1.
Are you saying that that answer is wrong?
No, I'm just saying I'm much faster.
Oh, okay, gotcha. Yes, I totally believe you that there's a faster way. All right. So, if you took 1 minus this, it would be faster. You're right. But I like the idea that OR is a whole bunch of this or this means plus, because OR means plus. All right. At least 2 papers. At least 2. So ask yourself, do these have at least 2? No, they only got 1. Does this have at least 2? No, that's only 1. This has at least 2. Oh, so it's this kind. All of these have at least 2. How about the one in the middle? It's got 3. That's at least 2. At least 2 means it could be more than 2. Okay, here's our first tricky one. Probability of A given B. Well, it's not out of 100% anymore. As soon as they say given B, you should add up all of the things that are in B because these are all of the things that are possible. And I said we'd keep coming back to that, and so we do. The things that are possible go on the bottom. So all of those get added up and go on the bottom. What is 0.056 plus 0.12 plus 0.12 plus 0.104? It's 0.4. Did you guys get 0.4 for that?
Yep.
All right. And then probability of A. Well, only these are possible. Don't grab the ones that aren't possible. Only those 2 have A in them. and are possible. So I can only pick those two. So that adds up to 0.176 when I add those two that I circled in black. This is what I wanted over what's possible. Wanted outcomes over possible outcomes. Okay, I think that's enough practice, so you're going to all go slip into a coma. So this is the part where we need to get into the worksheet, give you some free time, normal kids again. So find the worksheet, I'll tell you which ones to skip, and then we'll be done with the video for today. And yay, that's it. That's the last new material. And really it wasn't that new. It was just like they were the hardest ones you'd ever done. So now, what happens tomorrow is the ACT test. So you're not having the test tomorrow. What happens the next day? Well, this was new material. So the next day, we'll be doing the review. So Wednesday is the review. Thursday is your test. If you are missing the Thursday test, the only way I can get it to you would be on Wednesday after school in the testing room. And the only way that'll happen is if you ask me on Wednesday in class. We will together put your name on one so that it will be in the testing room. Otherwise, you'll show up and the testing room won't have it because you didn't put it in there. You have to put it in there. I'll help you, but you have to put your name on top. That'll happen on Wednesday. If that's you, because you really want to take it Wednesday after school, raise your hand. I'm curious. All right. So don't forget, in class Wednesday, we'll put your name on it. All right. Awesome. All right. So now you're looking at the worksheet. Can I see it? Thank you. Which ones does it say to skip?
It says 3 and 4.
Oh yeah, that's right. I already had to decide because I thought we were going to have the day today. So I said to do problems 1 and 2. I will stick to that. Just do problems 1 and 2. I will tell you that 3 and 4 are similar to things on the test, though. So, like, it's not like those are bad questions. If you want to do more practice, 3 and 4 also are good problems. Okay? So all you're required to do is 1 off of that homework. That's all I got for you for today.